In this lesson, we're going to talk about the graphs and the properties of functions. The first thing that we learn about graphs and properties is, I would say, more of a review for uh, everyone in the classroom. I want you to take a look at this table here. It basically gives the year, right? And then the price for the gasoline, right, per gallon. So notice how in 1980 the price was $3.41, and then the price kind of dropped, right? It just sort of dipped until a certain year around 1986-ish, and then it started to go back up again, right? So like this, you read these particular graphs that we have here. Now, if you take a look at if you take a look at this graph, it's basically saying the same thing that the table is saying, right? However, it's a nice visual depiction. So oftentimes, whenever we can have a graph available to us, we find this to be more visually appealing than to look at a table, because the table doesn't necessarily tell us the patterns. Over here, someone can look at this for just a moment and tell you, yeah, the pattern is it used to be kind of high in the 1980s, and then it sort of dipped down for several decades, and then it went back up again, right? So this book, it is only up until 2010, so you'll notice that the year, it kind of cuts off there, all right? Anyways, so one of the first things that we learn to do is to determine and to identify the graph of a function. All right, so I want you to take a look at these four examples that you have in front of you. This is a review because of the way that I taught you the previous lesson. This is a review, and you've already seen how to tell whether something is a graph or a function or not. Okay, so take a look at letter A that says this is the graph of y is equal to x squared. And you notice that if you make a vertical line, recall the vertical line test tells us that if you make a vertical line and the vertical line and the graph touch only at one spot, then this is considered to be a function. Now don't get confused between this and a horizontal line test. A horizontal line test is to test if something is a one-to-one function. So if you're wondering, is this one-to-one? No, it is not, because it would fail the horizontal line test. The horizontal line would touch at more than one point. However, because we're just trying to identify graphs of functions, that's as far as we take that example. All right, let's take a look at the second one in letter B. This is the graph of y is equal to x cubed. Notice how any vertical line that you were to make on it would certainly be touching only at one point. And so once again, this is a function. All right, let's take a look at graph number 3. Notice in graph number 3, it's basically a sideways parabola. We'll eventually come to discovering how to write that equation, but this is x is equal to y squared. And if you make a vertical line now, you'll notice that the vertical line touches at more than one point. The same vertical line is touching at more than one point, and you can't have that happening, so this is not a function. All right, and finally, take a look at the circle at the end. In geometry, we learned to make the equation of a circle. The equation of that circle is x squared plus y squared is equal to 1. Same exact logic. Notice how at 2 points the line runs into the circle. We can't have that for a function, so this is not a function. And remember, the logic is this. Every time you have an x value, you can't have two y values. I mean, obviously in these graphs you do, but because there's two y values, you can't define a function as simple as you were to able to define in those and those two graphs, right? So these are not function graphs right here. All right, now this is the slide that we spend, I would say, the most amount of time on. And basically what we do here is you're going to have a homework question that really mirrors the same exact question that you're looking at here, okay? So we're going to look at this graph and we're going to answer several questions about the graph, all right? I will do my best to fit the answers in right next to the questions themselves. Otherwise, what we'll do is I'll write them on the side if I start running out of space, because it seems like there's less space there, okay? So here is the graph. If we were sitting in class, I would certainly have paused for about a minute and I would have waited for you to make a really nice large graph, a really large graph on your notebook paper. So we're going to be reading graphs, and part of reading graphs is to be able to tell all of these things about the graph, right? And so let's go ahead and get started. Letter A, it says find the function at 0, all right? The answer to that is for you to go to where x is 0. Remember that this is considered the graph of y is equal to f of x, all right? And so your job is to go to where x is 0, right? Where x is 0, and go ahead and find the y value there. And so the y value at that point would be also a 0. So I think it would be advisable to write the answers in this void here. So the answer to letter A is f of 0 is equal to 0. All right? But then there's another question there. It says, what's the f of 6? Well, the f of 6, let's take a look at. If you go to where x is 6 right over here. And what's the y value when x is 6? It's also 0. So the f of 6 is equal to 0 as well. By coincidence, they're both equal to 0. All right, so we got our first answer there. All right, now let's go ahead and go to letter B. All right, I'm just trying to find the right size of a marker, but that's not that simple in this program. So letter B. Letter B says find the f of 2 and the f of negative 2. So here it goes. Where is x equal to 2? Right here. So the function when x is 2, the function is equal to negative 2. That's how you read it, meaning the y value is negative 2. So you write down f of 2 is equal to negative 2, like that. Then the next question is, what's the f of negative 2? Very good. Now go to where x is equal to negative 2. Here's where x is equal to negative 2. What's the y value there? This time it says negative 2 comma 1. In other words, when x is negative 2, the function at negative 2 is equal to 1, i.e. the y value is 1. And so you write down that the function at negative 2 is equal to 1, like that. All right, let's continue now with letter C. Letter C says, is f of 3 positive or negative? Okay, so let's take a look. Go to where x is 3, right? X is 3 right around this point here, right? This is where x would be. Notice how they haven't clearly written a coordinate for it. However, we're not concerned about that. You know that x being 3 would occur between 2 and 4. So when x is 3, you don't know exactly what the y value would be, but you know for certain that the y value is a negative y value, right? Because it's underneath the x-axis. And so the best you can say about f of 3 being positive or negative, we can certainly say that f of 3 is going to be negative. Notice how when we want to say something is negative in mathematics, we say less than 0. That is what negative stands for. All right, let's take a look at the next one. Letter D. Letter D says, is f of negative 1 positive or negative? So once again, they're not concerned with you telling them exactly what f of negative 1 is. They just want to know whether it's a positive y value or a negative y value. So let's go to where x is negative 1. All right, so x would be negative 1 right about here, right? because that's -2, this is 0, so x would be -1 somewhere around here. Now, where is the graph when x is -1? It's right over here. Notice how that would give you a positive y value. Although you don't know exactly what it is, you know that it's certainly positive. So we'll go here and we'll write down that f of -1 is going to give you a positive answer like that. All right, let's continue. Now comes letter E. All right, letter E says, for what values of x is f of x equal to 0? So let's read that again. It says, for what values of x? Now this is where it gets a little bit confusing. They're not asking you y values. They're asking you to work backwards here, okay? It says, for what values of x, meaning where on the x-axis, let me get rid of this right here, where on the x-axis would you notice that the f of x is equal to 0? In other words, where the y value is equal to 0. Whenever you get confused by this notation, f of x, I want you to just remember what I told you, that y is equal to f of x. So if this right here is confusing to you, what you can certainly do is say, where is y equal to 0? Okay, well, let's go ahead and work backwards here. So let's find all the points along the graph where y is equal to 0. So the first point that we see is right in the origin. The next one is that x is equal to 4, and the last one is that x is equal to 6. So what's so common and what's so important about these three is each one of them has a y value of 0, right? So let's go ahead and write down the answer. We can write down that f of x is equal to 0 when x is equal to 0, x is equal to 4, and x is equal to 6, like that. All right? So it's quite straightforward once you understand what the question is really asking of you. All right? Let's go to letter F. Now, letter F, it takes a little bit more understanding, right? What letter F is actually asking you, all right, is telling you for what values of x. It's not saying just one particular value. It's saying, sorry, for letter F, for what values of x is f of x less than 0? Okay, now what happens here is students get really confused. What they generally don't understand is, how am I supposed to write all the possible numbers where f of x is less than 0? Okay, so let me think of it a different way. What do you notice is a pattern? Every time that you have a negative y value, right? Look at how many, you have an infinite number of negative y values underneath the x-axis, right? What do you notice every single time about these negative y values is all these negative y values, I think I just said it, are underneath the x-axis, right? These are all, I'm highlighting it for you in red, all of these would give you negative y values. In other words, it's not just one x value here. You can't just say, yeah, it's 0, 2, and 4. That's not true, because 1 would work, 1.1 would work, 1.2 would work, and so on and so forth. So how do you exactly say in mathematics that you are talking about all the values? All right, so this one has confused students in the past, so watch carefully. The way that you write this is you write down f of x is less than 0, right? When, and now what you do is you write down the interval notation, which you've done in inequalities. You write down 0 is less than x is less than 4. What does that mean? That means as long as x is a value between 0 to 4, right? Not including the 0 and the 4, because at 0 and 4, it's actually equal to 0. As long as x is a value, right? Here's x's. As long as x is a value anywhere between 0 to 4, we know that the graph is going to be in the negative section. It's always going to be less than 0. So one thing that I want to remind you of is when somebody tells you f of x is less than 0, it's the same thing as saying where are the y values negative, right? So just kind of getting used to that notation. It takes a little bit of time for students, but eventually they do wrap their mind around that. Okay, so that one was kind of confusing, all right, but it does segue into um, some other types of questions. The next one says, what is the domain of f? So in a previous lesson, we talked about how domain refers to the x values, right? So what is the domain of f? What are all of the x values that this graph takes on? So the easiest way to do this is to basically look at the leftmost part of the graph and the rightmost part of the graph and ask yourself, from where to where does this graph go? All right, so we can go ahead and write down the answer that the domain of this graph is going to be from -4 on the x-axis all the way to +6 on the x-axis. Notice once again I'm using an interval notation to talk about the domain. Here's what you don't do, and this is a common mistake students have made in the past. They start writing down -4, -3, -2, -1, 0, so on and so forth. And what they're not realizing is, why doesn't -3.5 work? Isn't that true that that's also in the domain of f? So when domain is asked, it's really saying, what are all the x values that the graph exists for, right? And so that would be every single x value. And notice how there's an infinite number of x values between -4 to 6. It's not just the whole numbers there. Then we use the same exact logic to talk about letter H, all right, which is talking about the range. In range, really the question is not from left to right, but more from top to bottom. So let's erase this piece right here. And now let's focus on the bottommost part of the graph. So take a look at the bottommost part of the graph, and the bottommost part is -2, and the topmost part is +3, right? So notice how that says +3 and that says -2. So when you are asked the range, really what it's saying is what's the bottom to the most top part of the graph. And so you're going to write down -2 is less than, now here's what's a little bit different, is less than y is less than 3. So when we talk about range, just kind of keep track of that. When we talk about range, we always use the y in the middle. When we talk about domain, we always use the x in the middle. But notice how for domain, you using the x is a pretty common thing. But the only time you're ever going to use a y in the middle is usually when they ask you for range. All right. So the bottommost part of the graph was -2, the topmost is 3. And again, you're basically communicating to people that this graph does not go anywhere below -2, and it does not go anywhere above 3. That's essentially what it's saying. Now, if you want to be a little bit more exact about this, it's technically equal signs underneath each one of these, because notice that the graph, it definitely does equal -2, right? The y being -2, it's actually there, right? There is a part of the graph that's there. So to be more exact, there should be equal signs underneath the domain and the range. All right, let's keep moving. Letter I. All right, letter I. It says, what are the x-intercepts? So if you don't know what an x-intercept is, an x-intercept is where the graph runs into the x-axis. So that's one way to look at it. Some people say that the x-intercept is where the y is equal to 0. So it's really your call how you look at it, but you'll notice that when y is equal to 0, here are your three x-intercepts. So you write that down, that the x-intercepts are x is equal to 0, x is equal to 4, and x is equal to 6. Or you can write 0, 4, 6. Now pause here for a moment. Haven't we answered the same question before? This is very important that you realize this. Notice that the question that we answered in letter I is exactly the same question that we asked and answered in letter E. So let's take a look at letter E. Letter E had said, for what values of x is f of x equal to 0? Whereas in letter I, it says, what are the x-intercepts? So I just want you to make that connection that what's being asked in letter E and what's being asked in letter I, they're exactly the same question, just being asked in two different ways. Okay? So just kind of keep track of that and try not to get confused when they ask you the same question, and don't think like, wait, I just answered this. Well, why are they asking it again? One other little piece of information that I'd like to mention to you is x-intercepts have a few different names. Another different name for x-intercept is it's called a root of a function. And a third different name for it is it's called the zero of a function. They all, this is such an important point that it's mentioned in different ways. So x-intercept, a root, a zero, all three of these are talking about where does the function equal to 0. All right, that's how important those points are, as we come to realize eventually. All right, now we're gonna do letter J. Letter J is something that you guys have been doing since middle school. It says, what is the y-intercept? Okay, so just like in a line, the line used to intercept the y-axis, and in x-intercepts, where does the graph intercept the x-axis? You can have multiple answers. You can only have one y-intercept. As long as you're dealing with a function, you can only have one y-intercept. Okay, so take a look at where does the graph run into the y-axis? The graph runs into the y-axis when y is 0. And yes, you answer the question in terms of y, not in terms of x. So you write down that y is equal to 0. That one's not that bad. Okay, now let's continue with this lettering. We're done with J, and we're done with the bulk of the reading this graph. But now here are some follow-up questions. All right, so let's take a look at letter K. All right, letter K says that how often. So notice how it's not asking you for a value. It's not asking you for a domain. It's saying how often. Right? Like for instance, if I were to ask you, how often do you do your homework, right? Or how often do you go to the grocery store in a week? So I'm not asking you when you went, I'm asking you how many times, right? So it says, how often does the line y is equal to -1? So if you did not know this from before, please realize that the line y equals -1 is a horizontal line, right? So it's a horizontal line. Yes, we've done it, but in a previous lesson, so it's possible that you have forgotten it since then. So a horizontal line. So let's do this. Let's find where y is equal to -1. Now notice that y is equal to 0 here, y is equal to -2 here. So when we say y is equal to -1, that's that line right there. All right? So we draw a line, right? And that line is y is equal to -1. It says, how often does this line that you just drew intersect the graph? So let's take a look at the graph is coming down, right? And there you go. There's that first intersection, number 1 intersection. It intersects the graph. And then the graph dips down, and then the graph goes back up again. And as it's going back up again, it hits the graph again. And so the line again, sorry. So how often does this line and the graph intersect? You write down twice. That's it. All right. Now let's take a look at letter L. Letter L says, how often does the line x is equal to 1 intersect the graph? So the same way that y is equal to -1 was a horizontal line, x is equal to 1 is a vertical line. So let's go to where x is equal to 1. So let's erase this. Let's go to where x is equal to 1, which is right around here somewhere. All right. And That's x equal to, if you're wondering how did you figure that out, it's because look, this is x equal to 0, that's x equals to 2. So where can x equals 1 be? It's going to be somewhere in the middle of the two, right? Now it says how often does this line intersect the graph? Well, it's very clear. It's only happening once, all right? So we write down once. And think about it this way. If this is a function, remember the vertical line test, it says that the graph can only touch once or less than once, right? So it makes sense that it only touches once. And as long as you're dealing with a function graph, that's always going to be true, all right? Now let's go to letter M. Letter M says, for what value of x does f of x equals 3? So now they're being more exact. They're saying go to where f of x is equal to 3. Be careful. This is not saying f of 3. There's a difference between being asked, there's a difference between f of 3 and f of x is equal to 3, right? The first one is saying that when x equals 3, this is so important for you to understand. When x equals 3, what is y equal to? That's what that first notation means. But the second notation, what it's saying is when y equals 3, because remember, y is equal to f of x. So when somebody tells you f of x equals 3 and you're getting confused, understand that this really means y is equal to 3. Okay, so when y is equal to 3, the question is really asking, what is x equal to, right? So those are two separate questions, right? They're not the same question. Be careful of that. So letter M says, for what value of x does f of x equals 3? Well, let's work it backwards, okay? We go to this graph again, right? And we find where the y is equal to 3. So where is on this graph the y equal to 3? And that so happens to be right at that stage. Notice how the y is equal to 3. So the question was saying, for what value of x does that y equals 3? So the answer is when we can write down f of x equals to 3 when x is equal to what? 5. So when x is 5, y is 3. All right. Notice once again that that question in letter M is different than the questions in letter A and B. Letter A and B were a lot more straightforward because they just asked you when x is 0, what's the y value? But this letter M is saying when the y value is 3, what is the x value? So it's working backwards there, all right? Finally, the last one in this set is letter N. Same thing. It says for what value of x does f of x equals negative 2? So f of x is equal to negative 2. Once again, work backwards. Find every place where the y is equal to negative 2. That only occurs once, and it occurs down here. So we make the conclusion that f of x is equal to negative 2 when x is equal to what? To 2. All right, so like that, we are done reading this graph. Okay, now this is more questions that I chose out of the homework just to be able to answer these with you so that when you're doing this by yourself, it doesn't lead to confusion and all, okay? So the instructions say determine whether the graph of a function the graph is that of a function by using the vertical line test. So first thing we'll do is we'll use the vertical line test. And if it is, then you may need to tell the three things. Please be careful. If it's not a function, you're not going to tell the three things. Only if it's a function will you tell those three things. All right, so let's go ahead and start with number 14 here. Number 12 here. Number 12 gives you a graph. And in this graph, we ask ourselves, is this a function? I.e., does it pass the vertical line test? So I'm not going to draw these, but draw a vertical line at every single point, or in your mind, just draw them and you'll realize that yes, the number 12 is a function. So as far as being a function is concerned, this is a function, okay? But we need to answer some more questions about it though, all right? It says, tell us the domain and the range, all right? So for the domain and the range of number 12, let's make some space over here and let's answer these questions, all right? So number 12, take a look at the left and the right end. Notice how there are arrows pointing on the left and the right end. What this really means is this graph will continue to go towards the left and it will continue to go up and towards the right. Because it's going to continue from left to right, when you're asked the domain of this, it's not -3 to 2. All right? Students make a mistake with that all the time. This one is going to be -infinity. Oops, sorry. -infinity. Sorry again. To infinity. All right, so like that. Now you might be thinking, wait a minute, you just did a question where you defined a domain. Take a look at that previous question. In letter G, when we said -4 to 6 instead of -infinity, infinity, look at the endpoints. The endpoints were actual endpoints. They didn't have arrows at the end, and that's why we had said -4 to 6. But in this question, in number 12, notice how there's arrows at the end. So it makes sense that the domain is -infinity to infinity. Okay, now what's the range? So we're still on letter A of this question. The range in this situation would be everything that is on the y's, right? So it's not very clear, all right? It's not very clear, but for most part, here is what we can say, is it looks like this graph will continue to go downwards and it'll continue to go upwards. Some may argue that it doesn't look like it's going to be going any further down. It looks like it's just going to go sideways. That would be a valid argument. This has been a confusing question for students in the past. So I will accept either of the two answers. You can say, because it is kind of ambiguous here, it's hard to tell. So you can say that the bottommost is 0 and the topmost is infinity. We'll accept that. Notice how this is written in terms of y. Or just for this question, because it's a confusing question, or if you write down -infinity, y infinity, I will accept that answer because it's not very clear whether this will continue to go downwards or it'll only go sideways and not go below the line y is equal to 0. Okay? Now, letter B says, can you find the intercepts? So notice how there are no x-intercepts. This graph is never shown to run into the x-axis. So as far as x-intercepts are concerned, there are no x-intercepts. No x-intercepts. However, there is a y-intercept, and that y-intercept is at 1. At 0, right? So that y-intercept, I apologize, when x is equal to here, let me, because I said two numbers, so I don't want to confuse you. So that's 0, 1, right? So this is the y-intercept, which is 1. So you can write down that y-intercept is that y is equal to 1. And when I said x is equal to 0, I was implying that when x is 0, y is 1. So that is the y-intercept. Okay, letter C. Letter C says, any symmetry with respect to the x-axis, the y-axis, or the origin. So we're going to check three things in this question, all right? If you were to, now symmetry is something you learned in geometry as well, right? There was a mini lesson in geometry that talked about symmetry. If you looked at this graph, at this function, and you split it down the x-axis, would the top and the bottom be the same value? And the answer is no. Sorry, it would be the same graph. It would be no, right? So this is not symmetrical with respect to the x-axis. Is this symmetrical with respect to the y-axis? In other words, if you were to split this right down the middle, Is the left side and the right side looking like mirror images? And the answer is no, they're not, right? They don't fold on one top of the other. So no x-axis symmetry, no y-axis symmetry. And finally, when we say the origin, this one's a little bit trickier, but when you talk about the origin, it's more like saying if there was a line going through here, is there a symmetrical side to the origin? And the answer is no. There is no symmetry with respect to the origin either. And so symmetrical to the x-axis was that. Symmetrical to the y-axis was this. And symmetrical to the origin is this. All right, we'll come to talking about that a little bit more in a moment. And so there is no symmetry with respect to the x's, the y's, or the origin. So you can write down no symmetry like that. All right, so that is the answer to number 12. Now, because we need the space to continue with the other questions, we're going to have to kind of table this and put it away for now. I don't want to delete it just entirely, but I don't think I have much of an option, so let me just put it here for now. Might need to delete it later though. Okay, now let's take a look at number 14. Number 14, first thing, really quickly, is it a function? Yes, it is. Okay, so this is a function. That's a check because it passes the vertical line test. Number 2, now tell its domain and its range. All right, so let's write down domain. So the domain of this, notice how this time there are endpoints. There aren't arrows here. There's endpoints. In other words, from left to right, it's specific numbers, and specifically it's negative pi all the way to pi, including those values. All right. Then the question is, what about the range? Well, range is all about the bottommost part of the graph all the way to the topmost part of the graph, right? So from the bottommost part all the way to the topmost part. And that would be negative 1 to 1. So we write down negative 1 is less than or equal to y is less than or equal to 1. Notice how they don't have coordinates labeled there, but we understand that the graph is definitely going there. Okay? Then the x-intercepts and then the y-intercepts. So take a look at very carefully. You'll notice that there are 3 x-intercepts. All right? Erase this. The first time that there's an x-intercept is actually negative pi. The second time is x equals 0. The third time, x equals pi. So the x-intercepts, there's 3 of them. There's 3 times the graph runs into the x-axis. X is equal to negative pi, 0, and pi, like that. All right, what about the y-intercepts? Well, same thing. The y is equal to 0. That's the only y-intercept, meaning when does the graph run into the y-axis? Only happens once, and that would be right there in the middle, right? And so that's the y-intercept. Y is equal to 0. All right, now this one's a little bit tricky. There is symmetry here, all right? And this is going to really help you understand what do you mean by symmetrical to the origin. First off, if you were to split this down the x-axis, notice how the top does not look like the bottom. So this is not symmetrical to the x-axis. So get rid of that. Then check the y-axis. If you were to split it down the y-axis, notice how this does not fold over the other one, right? That they're not mirror images of one another. And so there is no symmetry with respect to the y-axis either. So get rid of that. However, the origin, which is not the simplest thing for students to understand, this gets really confusing for them. Is it symmetrical to the origin? And the answer is yes, it is symmetrical to the origin. Now let me just show you a nice way to do this so that there isn't any confusion about it, right? One of the ways that you can check if something is symmetrical to the origin is the following. Pick a point on the graph. Try not to pick something that has a 0 in it. So for instance, that's pi over 2, comma 1, right? Check if there is graph at negative pi over 2, comma negative 1. I repeat, check if there's any graph at negative pi over 2, comma negative 1. And there is. And it's exactly a mirror image of what was over there. Okay? And so this is what we call symmetrical to the origin. So basically, if you take an x value and you reverse their signs, so if this is positive, then you make it negative. If this is positive, you make it negative. Is there a mirror and matching image of it on the graph? Yes, there is. So this is how you tell if it's symmetrical to the origin. Let me pick another point just to kind of drive this point home. Let's take this point over here. Pi, comma 0. Is there a matching portion of this graph at negative pi, comma 0? And the answer is yes, right? So what did I do? I switched the sign on the pi. You can't really switch a sign on a 0. So negative pi, comma 0 does have a matching piece of what was at pi, comma 0. So that is one easy way to tell if something is symmetrical to the origin. And so the answer is yes, it's symmetrical to the origin. All right. Number 16 should be a quick one. And why do I say that? It's because of the fact that in number 16, it fails the vertical line test. In fact, when we started the lesson, letter D, we had said this is not a function, right? Because it fails the vertical line test. So in number 16, that was an easy call. You just write down not a function. All right, and we're done with that. That's all there is to it. Okay, so once again, let's take this, all right, and let's just sort of move it here. Perhaps we'll need it, perhaps we won't need it, I'm not sure. So just to be on the safe side, I'm just going to move it over here, okay? All right, now let's continue with what we were doing. Number 18 is very similar to number 12. The only difference, and I'm not going to do the whole thing, but notice how this one has a finite domain. It's not negative infinity to infinity, right? So that's one little point to make, right? If you're wondering, is this a function? Yes, definitely it is a function because it passes the vertical line test. Its domain is from 0 to 4. Its range is from 0 to 3, right? Because the highest value it's showing you is 3. Is it having any intercepts? The x-intercept is 0. The y-intercept is also 0. Is it symmetrical to the x-axis, the y-axis, or the origin? And the answer is no. It's actually not symmetrical to any one of them. So number 18, I'm not writing anything down for it. It's pretty straightforward, and we move on to number 22. Number 22 is a function. Okay, so that's a check. Well, let's go ahead and quickly answer the questions for this. Let's find the domain. Okay, so here goes, domain. The domain of this function is, notice how this graph will continue to go left, it'll continue to go right. Now, a lot of students in the past have said, no, that's not true. It's continuing to go down. But if you look at it very carefully, not only is it going down, it's also going towards the left. And not only is it going down here, but it's also going towards the right. So in fact, when we talk about domain, we say that negative infinity, I don't know why I keep drawing commas today, to infinity. All right. Now, the range, though, is really tricky. All right. The range is really tricky. When I ask you what's the bottommost part of the graph, clearly this thing will continue to go towards the bottom. So there is no bottom part of the graph. In other words, the bottom is negative infinity, right? But the top is defined. There is a particular value on the top that the graph never goes above, and that value is 5, right? Because 1, 2, 3, 4, 5. And so this is the range of this graph. Sometimes you can also write down y is less than 5, by the way, and that's acceptable. Okay, then the question says find the x and the y intercepts. Very good. I see two x-intercepts. The first x-intercept I see is at x is equal to -1, and the second one is at x is equal to +1. So I'm going to write down x equals -1 and x equals +1, like that. Okay, y-intercepts. The y-intercept happens right over there. So y-intercept is y is equal to 4, like that. All right. Then comes the last question, is it symmetrical to the x-axis, the y-axis, or the origin? And the answer is no, because if you look at it over the x-axis, the top and the bottom don't look the same. If you look at it over the y-axis, and I know it looks a little bit tricky because it initially looks like it does work, but remember, we're looking towards the y-axis. So does that left piece have a mirror image on the right? No, it does not. Okay, this thing is a little shifted off. So no symmetry to the x-axis, the y-axis, or clearly the origin. So you go ahead and you write down that there is no symmetry there. All right, and so that's the next part of that lesson that we wanted to make sure that we're able to do. Okay, now this question will not take as long as the one that was above it. Again, this is a homework question that you're going to be assigned, so you have to be able to be able to do it. And without me doing one, you might get confused. So I'm going to do an entire question for you. All right. So number 24. It says, is the point -1, 2 on the graph of f? So the way that we tell if a point is on a graph is basically, notice how we're not given a graph, right? We're given an equation of a graph. So what we do is we basically plug the -1 into the function, and we check is the answer equal to 2, right? So you ask yourself the question, is f of -1 equal to 2? Because if it is, then this point must be on the graph. The function must be going through that point. So let's go ahead and try it. Plug in -1, right? So for letter A, plug in -1. F of -1 is equal to -3 times -1 squared plus 5 times -1. Right? And so -1 squared gives you +1. +1 times -3 is -3. -3 plus 5 times -1 is actually -3 minus 5. Right? And what's -3 minus 5? That's actually going to give you -8. So in other words, the answer is no. Right? It's not. And the reason why is because f of -1 is actually equal to -8. It's not equal to 2. So that point cannot be on the graph. All right, letter B. Letter B says, if x is equal to -2, what is f of x? That's pretty straightforward. In other words, find f of -2. So we go ahead and we plug in -2 into the function. That is not a concern for anybody. Everybody knows how to do that now. And so you end up with +4 times -3, which is going to give you -12. And then 5 times -2, which is -10. So this gives you -22. Letter B says, what point is on the graph of f? And then it says, what is f of x? Those are both saying the same thing. They both are saying that the value is going to be -22. They're just asking you the same question twice. All right? Now, letter C takes a little bit more time. Letter C says, if f of x is equal to -2. So let's slow down a little bit. Now they're saying that you're taking f of x, which is -3x squared plus 5x, like that, and they're saying it's equal to -2. What is the value of x? So you first equal it to -2. And now, all of a sudden, this becomes something that you've done in solving equations, is this is basically you gotta write it, this is a quadratic, right? It's a quadratic. So what we need to do is we need to solve it accordingly. All right. So the first thing that you do in solving a quadratic is you really want to get rid of this negative symbol. And so what we'll do is we'll move everything over to the right side. All right. So this is going to become 3x squared minus 5x minus 2, and that technically the 0 should be on the left side, but we'll put it on the right side. Okay. Now, the best way to try solving a quadratic is through factorization. All right, so let's see here. 3 multiplied by negative 2 gives us negative 6. All right, now two factors of negative 6 that add up to negative 5 should be 1, should be 1 and 6 with a negative on the 6. All right. Now, we can't do a simple factorization because notice how there's a number that's not 1 out front. So you have to write this down. 3x squared, and we're going to do this as quickly as possible because we've learned to factorize already, right? Minus 6x minus 2 equals 0. Then in the first group, x is in common, so you end up with 3x plus 1. In the second group, remember to copy down the subtraction sign. 2 is in common, so you end up with, again, 3x plus 1. Be careful, that's not 3x minus 1, that's 3x plus 1, right? And so the final factorization of this, let's continue it over here, is 3x plus 1 multiplied by x minus 2 is equal to 0. So when you're answering this question, right, recall when you're answering this question, you basically take each single piece and you equal it to 0 and you solve it. So let's solve the first one. If 3x plus 1 is equal to 0, that means 3x is equal to negative 1. That means x is equal to negative 1/3. And finally, x minus 2 is equal to 0. That simply means x is equal to 2. So let's go back to the question. The question said, if f of x is equal to negative 2, what is x? What points are on the graph of f? So when you say what is x, the two x values are negative 1/3 and 2. When it says what points are on the graph of f, then the points technically are the whole coordinate. All right. So the whole coordinate is the following. It's negative 1/3 comma negative 2 and 2 comma negative 2. That's how you write down that answer. And by the way, for letter B, we had said this already. When it says what point is on the graph of f, when x is negative 2, y was equal to negative 22. So technically the point on the graph was negative 2 comma negative 22. That's what a point means, okay? Letter D, E, and F, we're not as concerned about them right now, but if you take a look at letter D, notice when it says what is the domain of F, um, there is no x value that you can put in to this function right over here that would cause it to become undefined. Because there is no x value that will make this undefined, the answer to letter D, let's just go write it right next to letter D, the answer to letter D would be that the domain is from negative infinity, there I go with my commas again, negative infinity to positive infinity. Meaning you can put any x value that you like into this function and it'll be good. All right? Letter E, it says list the x-intercept, if any, of the graph of f. This is an important question. So what did we learn? We learned that when you have an x-intercept, y is equal to 0, right? In other words, f of x is equal to 0. So what you do for letter E is the following, right? You write down, here, let me continue letter E right here. you write down that at an x-intercept, you know that the function is equal to 0, right? In other words, just like in letter C, you made the function equal to -2, in letter E, you make the function, which is -3x squared plus 5x, equal to 0. So let's go ahead and write that down. -3x squared plus 5x, we set it equal to 0. And again, the way to answer this question is going to require factorization. Notice how there is an x in common, so you end up with -3x plus 5 is equal to 0. And therefore, there are two possibilities. Either that is equal to 0, which means x is 0, that was easy, or -3x plus 5 is equal to 0. So if -3x plus 5 equals 0, that means -3x is equal to -5. That means x is equal to 5/3. So the two x-intercepts of this graph are going to be x is equal to 0 and x is equal to 5/3. So let's write it in x equals 0 and x is equal to 5/3. Those are the two x-intercepts. Letter F says list the y-intercept if there is one of the graph of f. Okay, now same exact logic applies. When you want to find a y-intercept, this is a lot easier to do, and you technically have done this all through middle school. And now you guys are 10th graders, so even in geometry we did some of these questions when we did lines. Well, the y-intercept means x equals 0. So now you go back to the function, and the function was f of x is equal to -3x squared plus 5x. And this time what you do is you go ahead and you plug 0 into it, so you're finding the f of 0. What am I trying to say? The question y-intercept is literally just asking you to find the f of 0. That's all it stands for. So that is going to become -3 times 0 squared plus 5 times 0, which gives you 0. So the y-intercept is equal to 0, like that. All right. So this lesson is going quite long, and so we're going to do one last really quick exercise, and we're going to wrap this up. We're going to try to do this before the hour mark. Okay. It says match each of the following functions with the graph that best describes the situation. So this is an important exercise for you to be able to tell which one of these makes the most amount of sense, as this is the independent variable, that's the dependent, how is one related to another, and so you can pause the video and try doing this by yourself. Here goes. The temperature of a bowl of soup as a function of time. So how does the temperature of a bowl of soup go as a function of time? Does it go up and then it go down? Does the temperature just simply decrease like this? Does the temperature increase this way? Does it increase this way? Does it do this weird zigzag thing? And so the one that makes the most amount of sense is graph number 2. All right, when you put the bowl of soup out, here's the temperature on the y-axis, here's time on the x-axis. As time goes by, notice how the temperature is getting cooler and cooler in that soup. All right. Letter B. It says the number of hours of daylight per day over a 2-year period. So we're talking about the amount of daylight per day, right? The amount of daylight over 2 years. So again, you ask yourself, well, does the amount of daylight go like this? Does it go like this? And it's very close to number 1, but the correct answer really quickly is graph number 5. Okay? And again, it's because the hours of daylight goes on the y-axis and the 2-year period is on the x-axis. So when it's winter, we have less daylight. When it's summer, we have too much daylight, right? We can barely sleep. So it makes sense that that's the graph. Okay, letter C. It says the population of Florida as a function of time. So here's population. So the answer is graph number 3. Here's population. Here's time. And so the population of Florida, notice how as time goes by, the population of Florida is really going up. A lot of people retiring and stuff like that, moving over to Florida. So graph number 4. Students have in the past said, why is it not 3? It's not 3 because that's not necessarily the population going to like increase at like a constant rate. Although you could argue this, but you'll see that in letters D and E, that's a little bit more clear. Letter D, it says the distance traveled by a car going at constant velocity. And so the answer to this is graph number 3. So as this car is traveling, it's traveling the same amount of distance. All right, so distance is on the y-axis. Notice how whatever they mention over here goes on the y-axis, and whatever they mention over here goes on the x-axis. So as time goes by, and usually the x-axis is time, if you recall from science, right? So as time goes by, notice how the distance of that car is going up more and more. And finally, not because of process of elimination, but because it does make sense. The last one should be 1, all right? And the height of a golf ball. So here is the height of that golf ball as a function of time. So you hit a golf ball, right? The ball is going to go up, that's its height, and then it's going to go back down as time goes by. So it makes the most amount of sense. All right, so thank you for listening to the lesson and good luck with completing the homework.